Greetings, math magicians. Today we're going to continue section 2-8, and we're going to focus on absolute value inequalities. So our goal remains the same. We're going to graph two variable inequalities. Notice we're going to have an x and a y. The only difference, instead of a straight line, we're going to have a straight line that bounces. So, by way of review here, we're going to describe the graph of the function, and then we're going to graph it. So the description. First off, because I see the absolute value bars, instantly I know that this is going to be V-shaped. Now, because of the negative that's in the front, right there, I know that this will open downward. So it will look more like a rooftop. Second, because of this 4, this plus 4, and this minus 3, I know exactly where the vertex will be. So remember, we always have to take the opposite of what we see inside. So I see a positive 4, so my vertex is at negative 4 and positive 3. So it's opposite of what we see inside, exactly what we see outside. And lastly, this tells me about its compression right here. The negative already tells me it opens downward. So this right here says that if my parent function looks like this, then it's going to squash the function so it opens up a little bit more. So the slope here, notice it's in parentheses because we're only going to consider the down portion. The slope is going to go down 1 and right 2, and also down 1 and left 2. So I'm taking the down information there and making both the numerators here down, and I'm going to go left or right there. So I know where I'm starting at negative 4, 3. So if I were just to sketch it real quick, negative 4, positive 3 is somewhere over here. I'm going to open downward, and it's going to be a little bit more open. So notice that I'm not going to need as much those quadrants. And so I'm going to focus most of my attention on quadrant number 2. So here's my graph. And now I'm going to place my vertex at negative 4, positive 3. And there we go. And now I'm just going to do my slope, but I'm going to go in both directions, left and right, going downward. So down 1, right 2, down 1, right, left 2, excuse me, and down 1, right 2, down 1, right 2. So notice that's the situation. And essentially, I'm just going to draw rays going here. So, and there we have it. Now let's take a gander at what we're going to do here. We do want to solve and graph absolute value functions that are inequalities. So in this case, we're going to have less than or equal to, or greater than or equal to, or I said those backwards. And we are going to see that they're exactly the same as graphing a linear inequality. So first we determine the properties, we determine the style, and lastly we're going to determine which direction we're going to shade. So let's see here the properties. First off, with absolute value, most likely it's going to be a V-shaped, like so. We're going to determine which direction it opens. Is it up or down? Next, we're going to figure out what its slope is, and we're also going to figure out where the vertex is. What about the curve style? Like I said, because of the absolute value bars, it's going to be V-shaped, and we're going to decide if it's dashed or going to be a solid line, if we're including the actual line as the boundary. And lastly, we determine the shading direction. And of course, we are going to shade above or we're going to shade below, depending on the context. So let's look at example number 1. Number 1 is already in sort of like vertex form, excuse me, not vertex, more like slope-intercept form. So I do have my slope right here. I do have my vertex. So let's just go. The vertex here is going to be positive 3, positive 1. Again, the opposite of what I see here, exactly what I see there. Next, my slope is going to be 2. So because it's positive, I'm going to go up 2 and right 1. And I'm going to go up 2 and left 1. Next, I'm going to determine how to shade it. Now, my instinct says less than means I'm going to shade under, and because it's less than, I'm going to have a dashed line. So if I were just to sketch real quick what it's going to be, notice 3, 1 is somewhere over here. It's going to open up, go up to right 1, something like that, up to right 1. It's probably going to be dashed, and my instinct says that I'm going to shade under. But I will check a point. So notice here that 0, 0 looks like it should fit inside. So if I plug a 0 here, 0 here, it should work. But I'll do that last. So I see that my quadrant 1 is going to be where I'm focusing. So when I do make my graph, I'm going to focus on quadrant 1. So here's my graph set up, quadrant 1. Now I'm going to take my 3, 1 and plot that. There we go. I'm going to go up to right 1, up to right 1, and come back. Remember, I'm returning to my vertex, and I'm going to go up to left 1, up to left 1. Clearly, because of this, I'm going to dash the line. So dash, 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 arrow, dash, 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 dash. Remember what the dash means? The dash means that we just don't include that, the line itself, which means any of the points that lie on these lines here are not part of the solution. Points here or points here, depending on where I shade. Now, my instinct says because I'm the less than, I'm going to shade under, but let me just test that real quick. So does 0, 0 work? So the test can be mental, but I'm just going to plug it in right here for all of us to see. So the question is 0 less than 2 times the absolute value of 0 minus 3 plus 1? So we simplify this, and 2 here, the absolute value of negative 3 right there. 0 is less than, we'll skip a step here, but that's 6 plus 1, and 0 is less than 7. So that's a true statement, which means 0, 0 is a solution, so I'm going to shade underneath. Now, a couple different ways to shade. I'm a minimalist when we shade, so I tend to just go perpendicular to the line of motion pretty much. And just shade kind of like this. Now, why do I like that? Because then I can still read my axes. I can still figure things out. Some people like to get crazy and shade full on like this. If you can lightly do it, that's fine too. But I think that's a little bit much, so I try to keep it minimal. The next problem here is not quite set up like we want. So I'm going to solve for y when I isolate y by adding 6 to both sides. Now I'm in a position where things are a little bit more familiar. This actually, in the original form, can help to justify and see why we take the opposite of the inside. Remember, with the vertex, I take the opposite of this. So clearly the vertex is negative 2. And then we say, but over here, which is plus 6, by the way, plus 6. We say, oh, it's exactly what we see. Well, notice here, in this form, it's the opposite of what I see over here, because the 6 is with the y, and it's the opposite of what I see here. So now, they're actually both saying the same thing when it's in this form, which is similar to point-slope form. Anyhow, now I'm going to say 6. What else do I know? I see here the negative means that it's going to open downward, like so. The equal to part means that it's going to be a solid line. And I know that my slope is going to be 1 over 1. Again, I'm going to go down 1, right 1, and down 1, left 1. So it looks like I got a lot of information here. And my instinct says I'm going to shade above, but again, I will test. If I do a quick sketch here just to see, I know that negative 2, positive 6 is up here. I'm going to open downward like this. So I see that I'm going to need a lot of my, all of the quadrants there. So now we're set up. And let me plot the first one. Negative 2, positive 6 is right here. My slope says down 1, left 1, and down 1, right 1. So I'm going to hit all the corners there. I already know it's going to be a solid line, so I'll just connect the dots here. And now I'm going to shade under, so my instinct thinks. So 0, 0. Let me just walk through that verbally. and see what happens. If I plug a 0 here, is 0 greater than the opposite of 2 plus 6? So the opposite of 2 is 2, and so 0, 0 does not work. And I can't remember what I said earlier, but this says shade up. So indeed, I am going to shade above like so. So I know that 0, 0 is not a solution. I tested that, so I'm going to shade away from the 0, 0. Now on page 2 is your time to shine, so go ahead and practice those ones. And I'm going to do this last example down here where we're going to write an inequality for the graph. So let's walk through this. Remember what we need. Notice over here I have my function name. I have the absolute value because of the V shape, and I'm leaving some room here for my vertex and potentially for any scalars in front, but also my my inequality there. So clearly I see the solid line, so I do need to have an equal. I also see that I'm shaded under, so I'm going to say less than. Since the whole thing is opening upward, it opens up, which means the front is here is going to be positive, which I don't even need to write. And let me just count the slope here. From here to here to here to here, it's just going up 1, right 1, up 1, right 1, up 1, right 1. So the slope is 1. Now I'll write them both for now. The positive means up, the 1 means slope, but I don't even need to write that, but I'll simplify it in just a second. Clearly this point here is -4, and that's the ugliest 4 I've seen in a while. -4 and -3. So how do I interpret that? Well, remember, the -4 has got to be the opposite of what I see. So I'm going to put a +4 there, and over here in -3. Now that's kind of all ugly, so let me just clean this up to see what we get. Y is less than or equal to the absolute value of x plus 4 all minus 3. Notice again, the positive I don't need to write, the 1 is already implied, and these are my opposites. This says I'm going to shade under. Over here says the whole graph opens upward, and this tells me where my vertex is. All right, now your job is to practice those 3. And you are ready for the assignment from section 2.8. Have a great one.